Good afternoon, everybody. My name is Charles Adkins. I'm a Vice President of Consultings at ABB's EPM Advisor Services. And we're going to talk today about the fundamentals of the Clean Power Plan. And I guess it's pretty appropriate that this presentation is coming in January because, like all good people, one of my New Year's resolutions was to go on a diet. And this is an appropriate point to talk about a diet on carbon. Today, we're going to take a look at what is currently being discussed in the Federal Register and around the water cooler these days. We're going to talk about the fundamentals of the Clean Power Plan and what it means for that compliance. And for me, the benefits of always understanding the fundamental components is you understand how these pieces fit together and how they influence each other. And, of course, this sets up a modeling foundation for analysis that a lot of entities are going to have to face in trying to decide what type of plan to go forward with. So today we're going to talk about a brief introduction. I'm not going to spend a lot of time on the broad brush scopes of the EPA Clean Power Plan, but I will focus down on the analytical challenges that those of us that are utility analysts in power planning functions are concerned with. We'll also go into a little bit of a deeper dive to compare and contrast both a mass-based market and a rate-based market. And then the last bit will be a discussion about what are the foundations for modeling and what are some tips and tricks to use as you go through this process. And with the Clean Power Plan, I think a disclaimer is a pretty good thing to have. So before we begin, any questions, please submit through the chat window. If you have any questions following it, you can contact me or you can contact Kathy Bertrand. We'll also be sending out presentation to all registrants. And for more information on what EPM Solutions are doing for the Clean Power Plan, you can go to our link here at Energy Market Intel. So let's first of all, a brief introduction. We're ABB. We're a very large corporation. And our group is in the power systems. And we're generally about 250 employees. Many of you will know us by our various other names, Ventex, Henwood, Energy Management Associates, New Energy Associates, Midas, Global Energy. All of us, we're all now contained within the ABB organization, and we're still providing support to all our clients since 1975 when ProMod first came out. On our market intelligence footprint, EPM Advisory Services is where I am in the consulting group. Many of you are familiar with our data services, in particular the reference case, which is a fundamental analysis of the national grid and develops all the commodity forecasts that then feed into a typical planning tool. Velocity Suite is a tool for looking at and examining historical generator information, such as carbon emissions. And also these are coupled with simulation-ready data. This is data ready to go into models to conduct analyses, and they're coupled with the reference case. And, of course, at the very bottom is a software portfolio. And we're down there with the portfolio optimization area with ProMod, Strategist, System Optimizer, Midas, and PAR. Now, if you've been asleep for a while and you just woke up, you might know that the EPA has guidelines for emissions, and they're calling that the Clean Power Plan. And one of the important aspects of understanding this Clean Power Plan is that it is only affecting existing units that are coal and natural gas combined cycle. There is a class of unaffected units, which are small combined cycle, small CTs, team host providers. And in future resource additions, we really haven't seen coal being seriously considered for future resource in the last 10 years. So we're only looking at the existing affected units, and those are the typical coal plants and also the natural gas combined cycle plants. Now, in this process, states and regional entities are developing these standards of performance, the emission standards, and then also looking at emissions reduction trading. And all this is designed to reformat the way we generate in order to reduce carbon emissions. And so we're going to take this block of affected units, and in this example, we're keeping half of those units operating, and then we're augmenting their operation with either block 1, which are heat rate improvements, block 2, which is shifting existing natural gas to augment existing coal, and then the big block, the gray block there, is block 3, where we're putting in renewables to offset our carbon-emitting generation. Now, the plans have been posted in the Federal Register, and basically between 2016 and 2018, states have to file their implementation plans for compliance to begin in 2022 and for full compliance by 2030. So what are the analytical challenges? I used to work at a G&T here in the state of Georgia, and I was in the generation planning group, and kind of always felt like I was at the bottom of the analytical chain there. But basically, for any type of corporate planning, corporate impact assessment, you have to have an assessment of market commodities. And I'm only representing electricity here, but that includes coal prices and gas prices to feed in that planning function. With the system implementation plan, we're going to now have to factor in a couple more elements. First of all, what are the carbon limits? And then what is the marginal cost to remove carbon? Now, throughout this presentation, I will be using L to denote a limit and little lambda to denote a marginal cost. So it could be the marginal cost of energy or the marginal cost to remove carbon, and it will be denoted as you see here. And all of this is being developed in the next 2 years at the state and regional level. And there are a lot of pieces that have to work together and a lot of pieces that have to be resolved in order to fit down to our planning to see what we're going to do. So these state implementation plans, we've identified these components, but the standards of performance get to what will be the emission rates and how will they be translated to state and federal. The MathBased versus RateBased is the emission standards, and that's kind of the nuts and bolts of the whole process. But then also being developed are these market-based trading programs. And so we're going to talk about what these tradable compliance units are going to be. But the important thing to realize here is that everything that the EPA has been working on has been based on averages. And the one thing we know with averages is there will be people above that average and people below that average. And so the challenge here today for the participants is to be able to look at these programs and they evolve and identify winners and losers. And to get to that, you have to have this fundamental structure for analysis. And that combines the commodity forecast that we've talked about, or this macro fundamental analysis, coupled with corporate databases, but also simulation-ready data for a database that is larger than your footprint. If you're going to look at a state, you need to consider not only yourself, but all the other utilities and all the other participants in the state. And last, we have to bring all these together through optimization tools to look at these various blocks to develop our compliance plan. All of these components are important because ultimately, as advocates for the utility and our ratepayers, we have to take all of these analyses and we have to determine what is the reliability impact, what is the ratepayer impact, and what is the shareholder impact. And all of this comes down to this sphere of advocacy, where with each of these various plans, you're looking at strengths, weaknesses, opportunities, and threats. and are using the sphere of advocacy to advocate for your ratepayers and shareholders for a program that is beneficial to everyone involved, but more so to us. That was just a side joke there. But at the end, after the system implementation plans, after these macro elements have been resolved, then we can get back to our day-to-day activities of determining compliance strategies and then all the associated tactics that will fall out of what happens in the next 2 years as state implementation plans are developed. So now let's shift gears a bit and let's talk about what is mass-based versus rate-based. And I'm going to go back to the diet analogy here, and basically, with a mass-based, this is the before picture. That's the picture your doctor takes of you when you start a diet, and this is your after picture. All right, so we have a strict limit in tons, and our unit our system will have to be below that limit. And of course, if we are over the limit, we will have to buy compliance tons or curtail our generation. And if we're under the limit, then we may sell compliance tons. Now let's contrast that with a rate-based program. In a rate-based program, here is our block of affected units that we talked about earlier, and it looks like a plate. I want you to think of it like a plate, because the difference between the mass-based and the rate-based is the mass-based has a direct calorific limit, but with the rate-based, we're going to redefine how we eat. So when you see that plate, imagine there's a hamburger, French fries, and a Coca-Cola. The key thing about this meal is the meat. So when we go on our intensity diet, we're going to reshape what that plate looks like. And we're going to keep the beef, but we're going to, like block one, which is heat rate improvements, we'll swap out the bun for wheat for whole wheat. And block two, which is swapping out natural gas to coal, we're going to swap out our Coca-Cola for a Diet Coca-Cola. And then block three, the most radical of these three components, that's going to take our French fries and turn them into carrots and celery. So we're going to achieve our diet by changing the composition of what we have. And of course, if we are over our intensity, we will have to buy compliance megawatt hours to put into our denominator. And if we're under intensity, then we may sell compliance megawatt hours into the market. So with that compliance mechanism, let's take a look at this is a fictional system that I developed. It's 4 companies, and it represents kind of a Midwest utility, a Southern strong nuclear utility, as well as an East Coast utility, and also a utility, this company 4, that has nothing but natural gas. Right, here we're just looking at, so the vertical axis is tons of carbon released. And we've looked at each of these entities under a base run, which is no limitations, then under a run with mass limits, and then under a run with rate-based limits. All right, and the mass-based and rate-based limits were comparable. And so we clearly see that both of these programs meet the intention, which is to lower emissions. But we also noticed that the rate base gives us a little more advantage in using our coal assets. The black box represents coal emissions, and the gray, the gas emissions. So the rate-based program, by allowing the renewables into the denominator, creates this extra value to run more coal. Now let's take a look at the company on the end. All right, there's something odd with this one, and you'll notice that it is exceeding. All right, under its base operations, it emitted X tons, and now under both a mass base and a rate base, it's emitting more. So we can imply from that it is generating more and selling to the other companies 1, 2, and 3. So let's take a little deeper dive here. All right, under a mass-based program, Company 4 is selling 400 markets to the interchange market. But because it's a mass-based limit, they are exceeding their target. So they are not compliant. And in order to be compliant, they need to buy 180 tons of whites to emit. Under a rate-based program, Company 4 is compliant. All right? They are a full natural gas. They don't have any coal resources, and so they are compliant in this example. And they are also selling 400 megawatts to the market, but they're selling, in addition to selling 400 megawatts, they're selling 400 megawatts of Block 2 compliant energy. This is classic Block 2, where you're taking natural gas and shifting coal generation to the natural gas. So, kind of a thing to follow the compliance protocols with the dollars. The key thing we see is that under a mass-based program, Company 4 is a buyer of compliance tons, and under a rate-based program, Company 4 is a seller of compliance megawatt hours. Now, these compliance commodities, you just need to think about them correctly. Mass-based is a ton. A ton is the commodity, and you buy a right to emit 1 ton. In a rate-based program, megawatt hours is the commodity, and you buy 1 megawatt hour of zero emission generation. So the next big question is, what is that price? What I've done is I've taken from the Federal Register the mass-based block prices that EPA estimates. Right? This is based on $30 a ton and then moved the associated Block 1 heat rate, Block 2 gas, and Block 3 renewable components. All right? And these are the mass-based goals. Well, the challenge is you need a set of rate-based goals that are comparable. And we have a change of units, and we have a change of kind of what we're using as our carbon emitter rate as an issue. So let's just step back for a moment and look at what this equation looks like to convert from dollars per megawatt hour, dollars per ton to dollars per megawatt hour. First of all, you have to convert tons to pounds, and then you have to multiply it by some emission rate in pounds per megawatt hour. Right. As Professor Stanford taught me at Georgia Tech, he didn't understand why physics students couldn't do problems. If you've got the units, the problem does itself. So when we look at the units, we've got dollars per tons times the inverse of pounds per ton, which is tons per pound, times pounds per megawatt hour, leaves us with dollars per megawatt hour. So we're going to take this $24 per ton, and we're going to convert it to this rate-based program, and we're multiplying it. The R in this case, the R, which is the rate emissions, pounds per megawatt hour, is 1,000. I've selected 1,000 because that was the target for those 4 companies to reach. The statewide target was 1,000 pounds per megawatt hour. So that means 24 times 1,000 divided by 2,000 gives us $12. Now, conversely, we can work that the other way by inverting our emission rate, and we can convert from $19 per megawatt hour to $37 per megawatt hour. Now, one of the key components is, what is that rate? All right? And in this example, I used 1,000 pounds per megawatt hour as the system target. And that converts it to $1 per megawatt hour of 12. If I was to use the fossil average, then it would be 15. And if I was to use the gas average, it would be 9. And if I use the specific unit that Company 4 has, it would be $10.80 because they emit at 900 pounds per megawatt hour. All of this is to just show that what rate you use to transact these components is going to be important and it is a key attribute to figure out as you're going through this process. Now, let's step back and let's take a look at what's going on here. All right, Company 4 in a MathBased has to buy tons at $24 a ton because it's block 2. In the RateBased, they're selling compliance megawatt hours, block 2 compliance megawatt hours, at $12 a megawatt hour. And again, the emission rate down there is the system target of 1,000. So let's kind of run the numbers. That's the way you always do it to kind of understand how these dollars work. For compliance, Company 4 has to buy 180 tons of compliance coal, and that's going to cost them $4,320. At the same time, they are selling 400 megawatts at the system marginal cost of $30 for a revenue of $12,000. Right, so if I was Company 4, in addition to my interchange revenues, I would want to bump up my sales price to include the cost of compliance. So really, in order for me to break even, I've got to collect $16,320 over 400 megawatt hours to break even, and that's equal to $40.80. On the rate-based side, remember we're using a system average of 1,000, so we're now selling 400 megawatt hours of compliance energy at $12 per megawatt hour for revenue of $4,800. In addition, we're selling to the market at our marginal price for a revenue of $12,000. And so interchange revenues plus our compliance revenues is equal to $16,800, and if we spread that over 400 megawatts, we come out to $42 per megawatt hour. All right, so when we look at these two programs, MathBased versus RateBased, you might think, well, hey, those numbers ought to come out to be the same. Well, it's not true, because really what's happening is, under the MathBased approach, Company 4 is generating off-system sales of 400 megawatt hours at an emissions rate of 900 pounds per megawatt hour. On the rate-based approach, we have converted the dollars per ton to dollars per megawatt hour based on the system target intensity, which was 1,000 pounds per megawatt hour. So really, when I talk about understanding the averages and understanding the key components, this is what I'm driving towards. You know, there are key components that are determined in national averages, which are going to play differently for every individual unit out there and every individual utility out there today. So let's just kind of look at a summary. Basically, MathBased is tons, rate-based is intensity. You can sell or bank allowances, or you can purchase compliance allowances. Under the rate-based, you purchase and sell compliant energy. And, of course, the compliance commodity is tons, megawatt hours, and the marginal cost is reflected in dollars per ton and dollars per megawatt hour. So let's kind of step now into the details and look at the modeling foundation that is required to do this type of analysis. First of all, you know, in determining what is the compliance price of a commodity, it's important for everybody to understand how these tools kind of do this dispatch. And basically, a typical tool will solve for compliant and reliable redispatch of the coal units. And it's going to do that using a shadow price of coal. And basically, that shadow price is going to force all or a portion of that unit uneconomic. And so, you know, in this example, we want to reduce our coal generation by 50%. Then the second half of that coal unit, it's a bid price that's above the marginal price to ensure that it won't be dispatched. Now, in coming up with that compliance commodity price, you know, you've got to have all of these critical components available. You have to have the engineering costs for all of these various components. You have to have the state implementation plan and how its rules are going to work. And then, of course, you need to bring that all into your modeling framework. And all that is at achieving and finding and determining these three key components. Now, in a mass-based versus rate-based analysis, it can be intimidating or it could be simple. It's all how you look at something. But basically, you're looking at how can you use these combinations of Block 1, which is heat rate improvements, Block 2, shifting coal to gas generation, and Block 3, shifting coal generation to renewables. And all of that is to get us to this new diet that's going to help us lose carbon pounds. So, looking at Block 1, heat rate improvements, this is a classic differential cost analysis. Basically, the approach to do this is all projects independently evaluated and ranked according to their benefit-cost ratio. You select the best project, lock it in, and then reevaluate the remaining projects independently, lock in the next winner, so on and so forth until you've locked in all of your profitable projects and then rejected any unprofitable projects. Block 2 is shifting generation to existing natural gas combined cycle. You know, the easiest way to look at this is to force all natural gas generating assets to their maximum utilization. Let's say that turns out to be a 75% capacity factor. Basically what we're doing here is before the emission limitation, we have coal that's operating both generation and also it has a piece that's unavailable. And our natural gas has this large block that is available. This is the piece we're focusing on. And by raising that dispatch factor, after the Block 2 redispatch, you'll see that coal now has a big portion that is not there for emissions, and you'll notice that the natural gas is now fully utilized. The next big piece is Block 3 and shifting the generation to new renewable resources. Now, one thing is there is a reality in planning tools. Not all planning models have an intensity optimization function. However, all planning models do have a limit optimization function, either emissions limit, fuel limit, renewable portfolio standards, etc. When you step back and look at this, you think, well, if I'm going to do a rate-based program and I'm going to use a mass-based tool, I have to iterate. Well, you may not have to do as much iteration as you think, because at this point, when you're down to Block 3 replacement options, you know, there's not a whole lot of real dynamic decisions here to be made. So you can simply compute the amount of Block 3 replacement energy that you need. All right, and you can do that through closed-form math. You know, here we have the intensity equation, which is the sum of effluent emissions from affected units divided by the generation from affected units plus the generation from Block 3. For simplicity, I've not included ERCs in here. But by simply reformatting that equation and solving for the change in limits from your measured intensity to your target intensity, say you're currently at 1,900 pounds per megawatt hour and you want to get to 1,600 pounds per megawatt hour, you can simply look at this in terms of calculating, if I want to have 10,000 megawatt hours of coal generation, I'll need to have 1,875 megawatt hours of generation, renewable generation. If I only wanted 5,000 megawatt hours, then I only need to add 938 megawatt hours of renewable generation. This is the beauty of the rate-based program. All right? The rate-based program, you know, your intensity at 5% is the same as your intensity at 100%. So you can use this tool and a sliding scale to look at how much you want to augment your carbon coal-producing generation with renewables. So it adds a new dynamic to the equation, but it lets you quickly get at what do you need to add in order to meet that Block 3 generation resource requirement. Now, a quick guide to computing the carbon intensity. This is an issue that clients run into all the time. They go, oh, we got all these carbon influences, but it doesn't calculate intensity. Well, generally, when we set up something like this in a model, we'll have a modeling effluent. And so, here's some traditional modeling effluents in tons per MBTU. Unit 3 is an unaffected unit, so it may have a carbon emissions rate of 210 tons per MBTU, but because it's an unaffected unit, we don't have to capture that and look at it. And then you'll also notice that I've included new renewable here. Well, here's a modeling trick. If you create a second effluent, and in that effluent put the heat rate. And so here you'll notice that I've included new renewable by giving it a heat rate of 1. When it goes and calculates how many tons were created, it will also create a comparable generation list that goes with it. So as you can see, Unit 3 is excluded, and the new renewable generation is included. And by doing a quick summary of this, you can very quickly get to your carbon intensity calculation. And in this example, it's 1,700 pounds. This is an important aspect to use using that heat rate because, not only would it be important for calculating what your carbon intensity is, but that is also going to be what your compliance mechanism is going to be. So now I want to go through a couple of just key points as we go through this. The evaluation of state implementation plans, it requires that you have a database that includes all market participants. I mean, you can see what an implementation plan does to you, but the real value in your advocacy for what the state does is understanding how those benefits and costs are going to be shifted. Another element is to know your data sources. When you're getting these commodity forecasts, it's very important to understand what they represent and what is included or not included in the various commodities, because you will need to, if they're all separate, you'll need to bring them all together at some point. And throughout all of this, data preparation is a key. Math-based optimization models can be used to evaluate rate-based state implementation plans. Compliance can be accounted for, which will alleviate the concerns for leakage in a mass-based program. And the last component is you really have to keep a keen eye on economy interchange. I mean, any model you get, the thing you do when you curtail generation is going to go to the external market. And you have to make sure that external market is either compliant or non-compliant. So as you go through this process, economy interchange is a key component that needs to be addressed and considered as you go through this process. Now, getting back to the slides at the beginning, this advertisement, when it comes down to all the components that are needed to look at this clean power plan, Ventex has a series of sources that will fit all of these bubbles for you. We have a reference case as well as many other entities that do. We also have, combined with that, simulation zonal-ready data that's ready to run in Strategist, ProMod, System Optimizer. And then we also have the portfolio optimization tools, the Strategist, System Optimizer, ProMod, all the tools for looking at the various compliance programs. At this point, I want to take a deep breath and let's see if there's any questions or any place where you'd like me to spend more detail. I tried to be very cognizant of the value of your time today, and so we have 20 minutes left over.
Hey, Charles, there was a question in your chat that I forwarded to you, and then there's a question in your Q&A window as well, so if you could address those perhaps.
Okay, well, one question I have is, does the potential income from plants based on M&R options give a new plant asset value that will impact the long-term debt profitability and ability to finance utility? I'm going to have to think about that question. I don't know that anything that's going to come out of mass-based versus rate-based is going to fundamentally change the way the utility industry operates. But this question I'll have to give some more thought to. I'm sorry, I meant to ask, what is the meaning of the difference between mass versus rate approach? You know, a mass is a direct calorific limit. You know, you're going to only emit X amount of tons, whereas a rate is you're going to adjust your operations and you're going to augment your operations with renewable resources. That's kind of the key that gets us to this value right here. Oops. That is the key that gets us to this value right here. You know, because the rate base allows those renewables to get into the denominator and thus the rate of emissions. All right, we have a question. Someone used strategists. Could you further describe how to use a second influence to allow the program to model a rate-based scenario? It doesn't. It is a quick tool to let you very quickly capture the components that you need in a rate-based paradigm. You know, if you think about, you know, you've made a run, now do I have to go through this list of units and pick out the right units and add them up? But by using a modeling of fluent that is set to the heat rate, then you will always get your generation back out. And so when I describe this, it is a way for you to very quickly aggregate and sum all of the components that are needed to make this intensity calculation. All right, I have a question about how the emission mass rate and rate were determined for the four-company example. Those were really designed to be representative of regional entities. Company 1 is designed to be like a Midwest energy company like DTE, NIPSCO, IPL. Company 2 is designed to be like a typical Southern company, Georgia Power type company, lots of coal, lots of nuclear. Company 3 is more of what I would call a mid-Atlantic utility, nuclear in the mix, but a different mix of components. And then Company 4 is all natural gas and renewables. So the emissions and mass base were just based on a 30% reduction over their base operations. I had a question. It sounds like rate-based is often preferred. What are the cases or factors that would make mass-based preferable? In my view, rate-based, the value comes right here with the fact that the rate base allows you to utilize renewables to offset your coal. And it doesn't really put a limit on how much your coal operates. It just says that if it's going to operate this much, you need to augment through the denominator this block 3 compliance megawatt hours. And what makes a mass-based preferable is everybody understands what a mass-based program is. All right, and that's the simplest answer. A mass-based program, everybody knows it. They're familiar with it. They've experienced it with the SO2 and other compliance mechanisms. So the major benefit for mass is just familiarity and ease of use. RateBased has a lot of inherent advantages because of allowing the renewables to augment your coal. Somebody would ask the question, can you choose whether you're a mass or rate-based compliance mechanism? No, that's what's going to be determined at that macro level. You know, that is going to be determined by, you know, this whole process here. Your state will make a determination. Your state or region will make a determination, and then everybody will either be mass-based or rate-based. Now the question, is it easier to keep your existing nuclear generation under a mass-based approach rather than a rate-based approach? I guess my off-the-cuff answer is it doesn't really matter because your existing nuclear is a part of that existing unaffected set. You know, there is an issue of leakage, and the issue of leakage is how do you replace your coal? And the intent is that under a mass-based, you're not using combined cycles to offset your existing coal or anything else to offset your existing coal other than blocks 1, 2, and 3. There's a question about the WCC, and do you foresee regional cooperation as likely for states to keep the big coal plants operating? I absolutely see that. I absolutely see that as a key requirement to make this functional. You know, when we get down to this question of who are the winners and losers, you know, this is the component that we want to focus on. This is the component that we want to make our advocacy on. I'm just going through a couple of other slides. I have a question about which mechanism is commonly employed. As far as the United States, the common is mass. We don't have any other rate-based incentives, but except for the one that's on the plate for us now. I think I've exhausted some of the questions. These are some good questions. You know, this has been a very difficult concept to get through, and I can certainly appreciate where everyone else is in this situation. Well, without any other questions, just like to, first of all, you know, these reference case, I want you all to be aware of what the reference case schedule is. And you can always go to our Energy Market Intel site to see webcast and white papers. And just an initial advertisement for what all we can do. And last, if there's any questions, feel free to send a note. My contact information was at the beginning. Within our group, we have Erdal Kara, who is a project manager for our Clean Power Plan initiatives, and many of you have probably spoken with him. Tom Sweet is the project manager for the reference case. Dana Berry is our host for today. And Rick Hunt is our simulation-ready data resource. And with that, Dana, I will turn things back over to you. Good luck on your Clean Power Plan implementation.
Yes, and thank you all for joining us today. We're going to go ahead and end the call. If your questions were not answered or we missed them, we will address them offline. So thank you for your time today, and you all have a great day.
Thank you, ladies and gentlemen.